Alright, let's talk about range-based for loops. So in C and C++98 and C++03, you have your standard for loops as part of the core language. And standard for loops are pretty great because you have a lot of control over the index. So you can do whatever wacky thing you want with the index, right? You could initialize an array just using the index, and then you'd have, a series of numbers increasing or decreasing or, doing whatever you want. You could also have specific behavior at the beginning or end based on the index. But you don't always want all that control. Maybe you don't want to have specific behavior at different points. Maybe you just want to do a simple operation for each element in the container, which is it's a very common thing that you want to do. So if you don't care about the index at all, you could use iterators, but the problem with iterators is that it's more writing than with a standard for loop. Look at this piece of example code that I have here. So I'm doing much the same thing that I was doing up above with the array, but I'm using a vector, and I'm using a vector iterator to walk the container. So the problem with the iterator is that the type name takes up pretty much this whole line, and that's no good because it's more writing than I kind of want to do. The other alternative is to use std for each in the algorithms library. But the problem with for each is that for each requires defining a function that gets called for each element in the container, and you don't always want to have to write a separate function, especially if the whole goal here is to kind of reduce the amount of code that you're writing. So, one can only dream of having a concise method of iterating a container. Well, as it turns out, C++11 delivers. So C++11 introduces range-based for loops. So in a range-based for loop, you specify the name of the element and then the container. And then the compiler, it will walk the container by whatever means it has to. It will use iterators if they're available. And then inside the body of the for loop, you just use that name of the element. So you can either walk by value, or if you need to modify the elements, then you can walk by reference, and that's also perfectly acceptable. So you can see here this first example is functionally equivalent to the code that I showed before, where I was walking the container and printing each element. This code down here, I need to, this is basically incrementing each element in an int array. So I'm walking the container by reference, and then each reference I can increment, and that'll modify the container's contents.